Welcome back. Hey, we got to talk about something kind of important. We're going to talk about how to add and subtract with exponents and how to multiply and divide with exponents. But in order to get there, I've got to clear up some terminology. Some things we'll be talking about in those future videos have to do with polynomials. So we have to know what a polynomial means. Why we need to know what a polynomial is, how they're created, is because when we talk about these operations, we'll be referring to parts of polynomials like monomials or terms, things like degree, coefficients, and it's important for us to understand those. So in this video, I'm just going to talk about the terminology we're going to be using for the next few videos, because when we say, hey, let's add a polynomial, you got to know what we're talking about. So let's start with some basics. What we're going to talk about in polynomials are these things called monomials or terms. So mono meaning singular, nomial, this idea of a name or term that we have. So monomial, when we say a monomial, what we're really talking about, we're talking about numbers and or variables that are joined through multiplication or through division. What that does, that creates a monomial, and we typically just call these things terms. So what terms are? Terms are these things in math, these little pieces that are numbers and or variables joined together with multiplication or division, not addition, subtraction. You see, that's where we get polynomials from. Poly meaning several. So what monomial means is single term. These things joined together with multiplication or division. Polynomial takes one or several terms, monomials, and joins them together with addition or subtraction. The big idea here is this. Terms are not joined together with addition, subtraction. Terms are joined together with multiplication or division. That's a big deal. So monomials are what we call terms. That's a term. Every single variable term has this thing called a coefficient. That sounds really fancy. Here's what it means. In a variable term, you're going to have a number out front. If you don't have a number out front, well, we'll talk about what the coefficient is there. You always have a number out front, no matter what. That number out front of a variable term, so right in front of your variable, is called a coefficient. Now, we've been dealing with a lot of this stuff. We just haven't put names to it yet. I might have referenced some of the names as we're going through, but I've never defined them. And so I'm defining what these things mean. So the number in front of a variable term with its sign is called your coefficient. We also have constant terms. So if we don't have a variable, variable means it can change. You plug in a number, that term can change its value depending on what number you plug in. If you lack a variable, well, the term can't change. It's called a constant. It's always that way. It's constant. We don't typically talk about coefficients for constant terms, usually just coefficients for variable terms. Now, every term also has a degree. So what the degree is, so the coefficient, that's just the number in front of a variable term. That's what we're talking about. The degree has to do with the exponents of the term. So when we look at a term, and we're going to do a whole bunch of examples here in a minute. When we look at a term, well, if that term has variables, then those variables have exponents. They have a power. Even if there's no power listed, it has a power. The degree is the sum of those powers. I mean, for goodness sakes, the terms are joined together through multiplication. So remember when we multiply exponents, we add the powers. The exponent will say we add. We just talked about that. So when we look at a term and we look at the exponents that are on top of the variables as superscripts of those variables, if you add those up, that would give you the degree of a term. I want to look at just 5 examples real quick to talk about that, to make sure this is not vague when we go through it. So here's what we should know. Monomials are numbers and variables multiplied together. That creates a term. Every variable term has a number in front of it. That's called a coefficient. If you have variables, you'll also have exponents. If you add the exponents of those variables, you're going to get the degree. That's what those words mean. So let's look at this. This right here, well, let's look. We've got 3b squared. That's a number with some variables, and they're connected through multiplication. If we talk about this as being a monomial, that just means a single term, some stuff joined together with multiplication and or division. That is one term. It's also a variable term because it's got a variable in it. So every variable term has a coefficient. The number in front of this variable term right now is 3. So the coefficient here is just 3. That's what we're talking about. So it's a monomial. We also just call it a term. It's joined together with multiplication. In fact, 3 and b and another b are all multiplied together. It has a coefficient of 3, that's the number in front of the variable, and it has a degree. The degree here is, well, it's just the exponents of the variables. We don't talk about the exponents of the coefficient. The coefficient is the number that's in front of that variable. We just leave it as being a coefficient. We don't start talking about the exponents of our coefficients as being part of our degree. That's a no-no. We don't do that. The degree here is just the exponents of the variables added together. That's what we're talking about here. It's just add up the exponents of the variables in the term. So one more time, this is one term. This is a monomial. If you want to call it a monomial, that's fine. It has a coefficient of 3. That's the number in front of our variables. It has a degree of 2. So the exponents, if I add all the exponents of just the variables, I only have one variable, it's got a power 2, the degree here is 2. That's what terms are. They're pieces of math, the numbers and variables, joined together through products or quotients, multiplication, division. We've got another one. So this is also a term. We have some variables here connected through multiplication. We have an x. We also have 3 y's all connected through multiplication. Now naturally, we're going to make the y's more succinct. We're going to call it y to the third instead of x times y times y times y, because that's kind of lame. It takes a lot to write out. So this is all connected through multiplication. This is the definition of a term, or the definition of a monomial. Now, I've also said that any term that has variables has a coefficient, no matter what. Well, there is a number out in front of this. It's not written, but that number is 1. In fact, you can think of this as 1 times x times, 1 times x times y times y times y, or 1 times x times y to the third. That is a variable term, a monomial with variables in it. The coefficient, if there's not a number written, is 1. So here we have a coefficient of 1. Now, let's talk about the degree. Let's get our degree correct. The degree involves the exponents of all your variables. I don't care about the 1 right now, but I do care that every one of your variables has to have an exponent, even if it's not written. Do you remember this? Like with your variables, if you don't have an exponent, you give it a 1. We practiced that in last few videos. So our degree is the sum of those exponents. Man, that makes sense, because if they're connected through multiplication, what I do with exponents is one level below what I see. I've said that like 50,000 times already. Kind of exaggerating, but at least 50 times. So if I have these exponents, now I can't make them one variable. They're different bases. But as far as the degree is concerned, you add those exponents. So term, yes. Monomial, yes, same thing. The monomials are terms. They're connected through multiplication. We have a coefficient of 1. We have a degree of 4. You would add those exponents. That's all I really need you to know. Let's practice a couple more. I have another single term. This is technically connected through multiplication. I have a number out front. I have 5 x's multiplied together. That's the definition of a monomial. That's a single term. The coefficient, can you think of it right now? The coefficient is the number in front of any variables. So this is a variable term. It certainly has a number in front of it. The number is, like this one, you can write a little 1 right there. The coefficient is -1. Coefficients always have the sign of the term in it. So if I have a negative out front, well, that's automatically a negative coefficient for us. Here, our coefficient is -1. What's our degree? The degree is the largest power that occurs, or well, the sum of the powers that you have on top of your variables. Here we only have one variable. So single term, yes, it's connected through multiplication and or division. We have a number in front, yes, that's our coefficient, that's -1. And our degree is 5. Term, yes, coefficient 3, degree 2. Term, yes, coefficient 1, degree 4. Term, yes, coefficient -1, number in front, degree 5. We got 2 more. That's a nasty one. Can you have fractions when we talk about monomials or polynomials? Yes, but there's a big but. When you have a term and we call it a monomial or polynomial, we can't have any variables in denominators. That right there, unless you can simplify it, right there, that would take away the idea of being a polynomial for us. So when you have fractions, you can't have any variables in the bottom. That's what I'm saying. So let's think about this. Is this firstly a term? Is it a monomial? Well, we have a whole bunch of stuff that's connected through multiplication. I see no addition, no subtraction. That's the big deal. If you have pieces connected by addition or subtraction, there are more than one term there. There are more than one term there. So right here we have multiplication, multiplication, multiplication. This is a term. So it's one single term. That's a monomial. Even though there's lots of stuff going on, we'd say all these pieces of math, all the numbers, all the variables, they're connected by multiplication or division. They're not being added. They're not being subtracted. This constitutes one monomial, not 1, 2, 3, 4, not 4 monomials. That's not what we're talking about. A monomial are pieces of math connected through multiplication or division. So this is one of them. This is a single term. Now, does that term have variables? Yeah, of course it does. Lots of variables. The number in front of those variables is your coefficient. It goes with its sign. So the coefficient, it's okay to be a fraction. The coefficient here is negative 1/3. Can you find the degree? So if we're looking for the degree is the sum of the exponents of your variables, including any variables that don't explicitly have an exponent written. So here, single term, yes, connected through multiplication. Coefficient, yes, we talk about variable terms as having a coefficient. It's the number in front, it's negative 1/3. The degree is 2, 3, 4, 5. The degree is 6. The degree here is 6. The sum of the exponents of your variables. That's the idea, the variable factors that you have in there. Last one. Individual, just single numbers without variables, those are also terms. They are technically monomials. We don't typically talk about coefficients here because the coefficient is defined as being the number in front of a variable. We don't have a variable. If we don't have a variable, then the degree of that variable, this is going to get weird. If we don't have a variable, then you could write a variable with a 0 exponent, because anything to the 0 power, I proved it a couple videos ago, is 1. So you could do that. For that reason, we call the degree of a constant term. So it's something with just a number. We call that degree 0, because you could write a variable with a 0 power. So the degree would be 0. We normally don't talk about this as being a coefficient of -4. Some people do, because you could write that exponent with a 0 power. Some people say, well, the coefficient's -4. It's kind of a, some people talk about it that way, some people don't. We're just going to consider that to be a constant, because there's really not a variable there with any power besides 0. We say that's a constant. There's no chance it's going to change. It's always going to be -4. So yes, that's a term. Individual numbers are terms. The term is -4. It has a degree of 0. And it's constant. Now, if we take these terms, these individual terms, and we start connecting them through addition or subtraction, there's a big change here. Terms are pieces connected through multiplication and division. So terms, monomials, are these things that are joined with multiplication and division. Numbers in front times variables at the back. Those are terms. We've talked about the coefficient as being the numbers in front, the degree as the sum of the exponents of your variables. If we start taking terms, monomials, and connecting them with addition and subtraction, well, we get more than one term. Technically, you can have one term or more, but what a polynomial is, this mini-termed thing, is when we take one or more terms and we join them together with addition or with subtraction. So terms are multiplication, division, joined together, these terms joined together through addition and subtraction creates this thing called a polynomial. Poly meaning several or many, nomial, this idea that we get a term from it. So you can have and this is going to, a little point of misconception. Some people would classify monomials and polynomials differently. Polynomials include monomials in them, so it's a larger class. So let's get this straight. Monomials mean one specific thing. They mean one term. That's what a monomial means. A polynomial says these monomials fall under the class of polynomials, but polynomials also allow you to have things with more than one term. So monomials are one term only. All of these are individual terms. Polynomials say, okay, that's cool, we're going to call you polynomials also, but we're also going to extend that so you can have more than one term. It's kind of like every square is automatically a rectangle. Not every rectangle is a square. Every monomial is automatically a polynomial. every polynomial is not automatically a monomial. So it's kind of a class system where polynomials include monomials in them automatically. So when we start joining one term or more than one term with addition subtraction, we start getting these things called polynomials. Now, polynomials have some very specific things. We have to have all positive exponents. Man, are there negative exponents? Yeah, we get there in several videos from now. We talk about negative exponents. It's like, what the heck is that? They're not that difficult. I'll explain it to you. Don't worry about it. We have to have all positive exponents. We have to have exponents that are not fractions. So that's another weird one. I trip out on that for a little bit. You can have exponents that are fractions. Yeah, they make square roots and things, and cube roots. They make radicals. It's pretty radical. We get there a ways from now, so not to worry. Polynomials for us are very simple creatures. They have all positive whole number exponents. Maybe make a little side note here that all the exponents are positive. They're also whole numbers. All the denominators must be constant. So your denominators cannot have variables. The reason why that is if you can't simplify them, then you would end up having negative exponents. That's a problem. That would go back to here. We'll talk about that in future videos. I just can't talk about it now. We haven't defined it. So for us, for right now, monomials, single terms. Polynomials include single terms, but then also have the ability to add more terms up. Through addition, subtraction, we can put more terms in there. All the exponents of those terms must be positive. All the fractions, if you have them, can only have numbers on the bottom. Now, the degree of a polynomial. Here's what the degree of the polynomial does. It says, look at all of your terms. We know that. Look at the degree of each and every one of your terms. Go, okay, I can do that now. 3, 4, 5, 6, 0. Find the term with the largest degree. That is also the degree of the polynomial. So the degree of the polynomial is the degree of the largest degree that occurs in any given term. So you look at your polynomial and say, hey, look at all my terms. What's the degree of all those terms? Don't add that up. Okay, don't do that. So just look at each term, say, what's the degree here? What's the degree here? What's the degree for each of those terms? Find the biggest one. That's the degree of your polynomial. We're going to practice just with these 4 examples. I'll give you one more example of something that's not a polynomial. There's already one up here that's not a polynomial, but I want to show you the whole denominators thing. So we'll talk about that. So and going through this whole thing, let's look at these polynomials. So I'm going to start classifying these as what the terms are, what the coefficients are, whether we have a constant term or a variable term, to get us really used to this stuff, because I'm going to be using that terminology exclusively in the next few videos. So let's check it out. The first thing I need you to get very good at is understanding what more than one term means. So when I look here, we have 2 terms. Terms are those pieces that are joined together with multiplication and division. If I have addition and subtraction, that distinguishes one term from another term. So while terms are joined together through multiplication or division, they're separated by addition or subtraction. So anytime you see a plus or a minus, notice not a negative, but a plus or a minus, you start another term. If we look at this, we have 1 plus right there. That means that we're going to have 2 terms. So our first term is positive. I'm always going to say positive or negative here. Positive 6y to the 2nd power. A second term would be positive 4y. Terms are always associated with the sign that's in front of them. So here, positive, it's pretty clear, but we would consider this to be a positive 4y. We'll talk about other terms when we have different signs in a moment. So this would be a collection of 2 terms. One is 6y squared, the other one is 4y. Both of these terms are variable terms. They both got variables. In fact, if I look at the first one, the coefficient here is positive 6. The degree would be 2. The coefficient of this next term, that's also a variable term, the coefficient here is positive 4. The degree would be 1. That's really what polynomials are. They're just these terms that we already know about that are added or subtracted. We can still talk about the coefficient of every term. We can still talk about the degree of every term, of every monomial. So, polynomials, this one has 2 terms. Coefficients are 6 and 4 respectively. The degrees are 2 and 1 respectively. The degree of the polynomial here would be 2, not 3. Now listen to why that is. What we do with exponents is one level below what we see. So what's below the level of addition when we consider exponents? Nothing. You don't get to do anything with those exponents. You can't add them. You can add a cross multiplication, that's fine. One level below multiplication is addition. But when we start talking about terms, different terms and their degrees, you can't add them because there's nothing to do below addition, subtraction. There's no operation down there. You get stuck. You go, I can't do anything. You're right. You can't. So we choose to take just the largest power that occurs, basically. So we look at this. The degree is 2. The degree here is 1. The degree of the polynomial is the largest degree that you see out of your terms. The largest degree here is 2. I hope that makes sense. I hope that you're getting that. We're going to try a couple more here. Let's do the next one. So terms, they're these things that are joined together through multiplication and division, or these things that are separated by addition or subtraction. We have, let's see, I see a minus sign and I see a plus sign. There are 1, 2, 3 terms. All of the terms are variable terms. That means they all have coefficients. The first term here is this entire piece, just like here, the stuff that's joined with multiplication is 4ab squared. So that's the term, positive 4ab squared. The next term would be, get this right, this is a big deal. Terms always go with the sign in front of them. I know that's a minus, but we are going to consider this term to be negative 3a squared b. Negative 3a squared b. You always take the term with the sign in front. Now, here's why that is. A lot of people don't ever get this, but here's why that is. Every time you have a subtraction problem, you can always change it to an addition problem. Polynomials really are defined as terms added together. So if we define a polynomial as these terms that are added together, then every time you see a subtraction, go, what about subtraction? You could change it to an addition. So every time you have a minus b, you could write it as, instead of subtraction, the addition of the opposite of that term. So a minus b becomes a plus negative b. Because we can do that, now don't worry, we don't have to ever show it, but because we can do that, you could change every subtraction into addition of the negative, adding the opposite. Because we can do that, we always consider this to be a negative with our term. Yes, I know it's a minus, but you can always change a minus to the sum of the opposite or the sum of the negative. So that lets us group that sign as a negative with the term that's right after it. That's why. That's why we get to do that. It's not magic. It's not that that magically changes to a negative. It doesn't. It's because through an operation, we can change subtraction into addition of the opposite. So going back to this, the next term is negative 3a cubed b. Cool. The next term would be positive 2b to the 5th. There's 3 terms here. Let's talk about the coefficients. So let's look at the first term. First term is a variable term. It's going to have a coefficient. The coefficient of the first term, 4ab squared, would be 4. Just the number in front of your variables. The coefficient of the next term, negative 3a cubed b. The coefficient is negative 3. It's the number with the sign that's in front of your variables. The next coefficient will be positive 2, the number that's in front of your variables. Now let's talk about the degree. So this is a polynomial with 3 terms. Let's find the degree of every term. Here we get, remember, every variable has an exponent. The degree here would be 3. That's a bad 3. The degree here would be 4. And the degree here would be 5. The degree of the polynomial is not 12. The degree of the polynomial is, well, look at this. That's the degree here, that term would be 3, degree here would be 4, degree here would be 5. Just take the biggest one. The degree of the polynomial is the largest degree that you have in the polynomial. You don't get to add up those exponents across terms. Add them up for one term, yes, we've done that. 1 plus 2 is 3, 3 plus 1 is 4. 5, there's only one variable there, the exponent's 5. The degree of this polynomial is 5. Not 4, not 3, not 12, 5. How about that one? Man, that looks nasty. You're right, yeah. This is not a polynomial. We don't get to talk about this. We're not going to talk about the degree that's defined for polynomials. So this is not a polynomial. We can't ever have negative exponents. Done. That's kind of a nice one. So while we still could say this has 3 terms, 1, 2, 3 terms separated by addition, subtraction, we can no longer classify this as a polynomial because of the negative exponents that we have. So we're not going to talk about that one. Next one, I want you to look through that on your own. I want you to see if you can identify these following things. I'm going to erase this and put one more example of a non-polynomial so we can really see what's going on and how to change it to make it a polynomial. Not through math, but just what would need to change. But for you, I want you to look at this and see how many terms you have. So ask those questions. How many terms do you have there? Once you've determined the number of terms, say them out loud, say them in your head or something. Determine how many terms you have and say each one. Find the coefficient of the variable terms. Ask yourself, what are the coefficients of the variable terms? If there's a constant term, call it a constant term. Once you've done that, I want you to find the degree of every single one of those terms, every single one of the monomials that make up the polynomial. Find the degree of each one. Once you've done that, find the degree of the polynomial. So that's the terminology I need you to know. So hopefully at this point, we're talking for, I don't know how long it's been, but you understand what terms mean. You understand that the terms are the pieces that are connected through multiplication and division. Terms are separated, giving us more than one term, if we have addition or subtraction. When we join terms together through addition or subtraction, we get this thing called a polynomial. It can be one term or more than one term. It can be tons of terms. And they're very common as we go further and further into mathematics. Every variable term is going to have a coefficient. It's a number in front, including the sign. Terms always include the sign in front of them for the reason I showed you a little while ago. Every variable term also has a degree. Every term actually has a degree, just constant terms have a 0 degree. The degree is the sum of the exponents of your variables. The biggest one of those that happens is the degree of the polynomial. So, last example of polynomials for us right now. This has, let's see, minus, plus, minus, minus. This has 1, 2, 3, 4, 5 terms. Hopefully you saw the 5 terms also. That's got 5 terms in it. The first term would be 5x to the third power, or 5x cubed. The next term would be negative. Notice the negative. It goes with that sign. Negative 2x squared y cubed. The next term would be positive xy squared. The one after that would be negative y to the third power. The last term would be negative 9. Terms are always associated with a sign that's right in front of them because you can always write minuses as plus negatives. You can always do that. Now let's go through the coefficients. 1, 2, 3, 4 of these terms are called variable terms. The last term is not a variable term. It doesn't have a variable. So let's talk about the coefficients here. The coefficient of our first term is positive 5. The coefficient of our second term is negative 2, the numbers in front of our variables. The coefficient of our third term, every variable term has a coefficient, is positive 1. We don't write the 1, but it's there. The coefficient of our fourth term is negative 1. We don't write the 1, but it is there. We really wouldn't talk about a coefficient of our constant. We would just say, hey, that negative 9, that term, negative 9, that is the constant. We'd say negative 9 is our constant here. Because you're adding negative 9, if you want to think about that, that's why we take the sign in front of our term. That's negative 9. Now the degrees. The degrees are the sum of the exponents in any given term. Here we get 3. The degree of the first term is 3. The degree of the second term is 1, 2, 3, 4, is 5. You see the 5. The degree of the third term is not 2, it's 3. Because we'd have 1 on the x plus the 2, that's 3. The degree of the fourth term is also 3. The degree of a constant term is 0. It doesn't play into the degree of our polynomial very often. So we'd have a coefficient of 5, negative 2, 1, negative 1. We really don't talk about coefficients for constants, we call them constants. We have degree of 3, 5, 3, 3, and 0. So the degree of the polynomial is just the largest degree of any monomial that occurs in there. The degree of our polynomial here is 5, 3, 3, 5. The degree of the polynomial here is 5. Degree 5 polynomial. That's the idea. That's the interplay between terms being connected through multiplication division and terms separated by addition subtraction. Polynomials are collections of those terms through addition subtraction. We can talk about coefficients, the number in front of variables, and degree, the addition, the sum of the exponents that are in any given term. The polynomials degree is just the largest degree that happens in any given monomial, any given term. Now, I was talking about something else. This problem could turn out to be a polynomial or it could turn out to be a non-polynomial, depending on what goes here. If I put a number like 4, that's fine. That's a polynomial. It's got a fraction. That's one term, 4x squared. That's another term, 7/4. Fractions are okay. The division part's okay, as long as we don't have variables in the denominator. So this right here, perfectly fine. As soon as I do stuff like 4x, that would not be a polynomial. We can say maybe it has 2 terms here, but we don't have a polynomial any longer because polynomials can't have any variables in your denominator. Or maybe we do x squared plus 4, also no longer a polynomial. We don't talk about these things when we're talking about polynomials. That's the idea. So that's what I need you to grasp. So before our next video, I need you comfortable with monomials. I need you comfortable with coefficient for sure. I need you very comfortable with degree, because the degree has a lot to do with whether or not we can add or subtract terms in a polynomial. The idea being, what you do with exponents is one level below what you see. So if I want to add or subtract terms that have exponents, what's below addition or subtraction? Well, nothing. That means that I won't be able to change my exponents. Remember that exponent rules only apply to exponents. So if I need to add terms with exponents, and I can't do anything below that, there's nothing to do with the exponents, so you can't do anything, they'd have to be exactly the same for me to add them. We'll talk about that when we talk about like terms in the next video. Watch that video and then we'll get on to how to add and subtract polynomials together. And these things will start making a lot of sense.